All right, in this video, I want to introduce radians and make sure we understand what's happening with that. So a radian is just another way to measure the size of an angle. Okay, so we can measure how big an angle is in degrees, or we can use what we call radians. Now, what happens with a radian is when this radius right here and the arc length that's formed here, when those things are the same. So like if I were walking here and then I walked the same amount along the curve, this angle that's formed, so arc length, we typically use a cursive L. I don't know why, it is what it is, length, I guess. So what we can say here is when R equals L, theta right here will be 1 radian. Okay, so that's how it's a way to measure the size of an angle, just like a degree would be. But in this one, 1 radian is what happens when the radius and the arc length are the same. It's that angle that's formed right there. Okay, so if I had in my circle, so let's say I go all the way around, and let's say my radius is 1. Well, if the circumference of a circle is 2 pi r, so if my r is 1, then my circumference is just 2 pi. So if I go entirely around the circle, what I have done there is I have gone 2 pi radians. So we always will start here. This is always our initial side. And then when I move through the quadrants, going quadrant 1, 2, 3, then 4, I am moving in the positive direction. So if I go there, if I come all the way back around, so if I've gone all the way around the circle, then I've gone 2 pi radians. So half of that is pi over 2. I lied. Half of that is pi. Half of that is pi over 2. So it's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And those are the radians going around the circle. On this one, notice I took 1, 2, 3, 4, 5, 6, 7, 8. I divided the circle. I divided that 2 pi by 8. And so each one of these, so we start here at 0. This is 1 pi over 4. This is 2 pi over 4, which would reduce to pi over 2, which of course we prefer that answer, but I'm just showing you how we get it. 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4 can be reduced to 3 pi over 2, and then here's 7 pi over 4. We get back over here to 8 pi over 4, and that's just equal to 2 pi. The one down here has been divided into 12 chunks, so if I take 2 pi and divide it by 12, what I get is that each one of them is pi over 6. So 0, here's 1 pi over 6. 2 pi over 6 can reduce to pi over 3. 3 pi over 6 reduces to pi over 2. As always, I want the reduced values. I just want to make sure you know where they're coming from. So after 3 comes 4 pi over 6, and that reduces to 2 pi over 3. Here's 5 pi over 6. 6 pi over 6 is equal just to pi. Here is 7 pi over 6. 8 pi over 6 can reduce to 4 pi over 3. This is 9 pi over 6 is equal to 3 pi over 2. This one right here, sorry, I ran out of space. 10 pi over 6 can reduce to 5 pi over 3. Here's 11 pi over 6. Then this one was 12 pi over 6, which is just 2 pi. So we're going to spend more time on the unit circle because that's what we're doing, and my kids will race me. So did you see how fast I filled it out? That's me talking. I can go faster without saying a word, so practice. Okay, what we want to say next is 180 degrees is the same as pi radians, which is half a revolution. Okay, or we might say that 360 degrees is the same as 2 pi radians, which is 1 revolution. Okay, so what I do in order to convert things, I think in terms of chemistry and the dimensional analysis we used to do. So I'll set up a proportion. So if it's 250 degrees, I want the degrees to cancel, so I'll put degrees here on the bottom, and then so this is pi. Now I could use 360 and 2 pi, but let's go with what's already more reduced. And so then this just equals 25 pi over 18. Now when it comes to radians, sometimes I'll write out the terminology. If I don't label it, it's understood to be radians. So be careful back here. When this is 1 radian, if I just say theta equals 1, okay, then that means that it's 1 radian. And keep in mind, too, that when I look at this, this is well, let's say I wanted to find, hang on. Say I wanted to figure out where theta equals 2 is. Well, this is approximately 3.14. Okay, so if I want to be, well, and this would be half of that, so like 1.57. So if I want to find 2 radians, I'm going to be somewhere over here, and it's going to be this angle going like that. So be careful. If it's not labeled, it's implied to be radians. Next one, 7 pi over 12 times, this is radians, so I want to put radians on the bottom, so pi radians. I should have written it out. I forgot. Whatever. When I multiply this, I think it's 135 degrees, but whatever. This is now 4 radians times pi. So the radians are going to cancel here, and this is 180 degrees. Notice, though, that there's no pi canceling. Okay, so 4 radians, if we think back to this one again, if this is 2 radians, 4 radians is going to be somewhere in quadrant 3. Because we're bigger than 3.14, but we're closer to 3.14 than 6.28. So this becomes 720 over pi degrees. So I think, if I remember from class yesterday, it's about 229 degrees. Whatever. Okay, the next one, convert 2.4 revolutions. So 1 revolution, well, is 360 degrees, so you can multiply that, or you could say 2.4 revolutions times 1 revolution, so the revolutions cancel, and then this is 2 pi. So you could say 4.8 pi. Typically, though, we don't mix decimals with pi. We would have said that this is what? This is 4/5, so 24 pi over 5 would probably be what we're more likely to see, but it's not the end of the world if you say that. Okay, let's go a little bit farther. Actually, this will be the next video.